This is Dr. G. Shankar, Department of Mathematics, BVRIT, Narsapur. Today I am explaining limit of a function, that is on limits. Before going to limits, first of all, now I am explaining neighborhood of a point. Neighborhood of a point. So what is the neighborhood of a point? For example, we are taking one real line. This is the real line. I am taking at x is equal to a. This is the exactly at x is equal to a. This right side is called as a right neighborhood. Right neighborhood. This left is called as a left neighborhood. The left neighborhood indicate a minus, the right neighborhood indicates a plus. This is a real line at x is equal to a. Some here this is called as a value is h. Here the distance value is also h. Now at x is equal to a, this is a real line. Some it is an a plus. A plus is nothing but here a plus h. That is a right neighborhood of a minus is nothing but a minus is equal to a minus h. This is a left neighborhood. Okay. Similarly, taking another real line. This is a real line at x is equal to 1. This is on some h. This is also h. Here the right neighborhood is called 1 plus, that is equal to 1 plus h. The left neighborhood is called as a 1 minus, that is equal to 1 minus h. Now here 1 plus is a 1 plus is equal to 1 plus h, that is on right neighborhood. 1 minus is equal to 1 minus h, that is on a left neighborhood. This is the major concept of neighborhood of a point. And another thing, x tends to 1. X tends to 1 is nothing but it is not x is equal to 1. It is not x is equal to 1, but x is approaches to 1. X is approaches to 1. Here x tends to 1 is nothing but x is not equal to 1, but x is approaching to 1. So here x tends to 1 plus is nothing but x is approaches to 1 from right side. From right side. X tends to 1 minus is nothing but x is approaches to 1 from left side. Okay. X tends to 1 plus is nothing but x is approaches to 1 from the right side. X tends to 1 minus is nothing but x is approaches to 1 from left side. This is the neighborhood of a point. The next, limit. So what is the limit? In limit, here left hand limit and right hand limit. First, left hand limit at x is equal to a. Left hand limit at x is equal to a. Then after that we will discuss right hand limit again at x is equal to a. Now first of all, your left hand limit at x is equal to a is equal to limit x tends to a minus f of x is equal to limit x tends to a minus f of x is equal to. So before going to left hand limit, first of all here a minus is nothing but a minus h. That is a minus is nothing but left neighborhood. Okay na? So a minus is equal to a minus h. But here h tends to 0 plus a minus is equal to a minus h. But h tends to 0 minus a minus is equal to a plus h. Are you understood? Here a minus is equal to a minus h. A minus is equal to a minus h. But h tends to 0 plus, the h value is positive. Again a minus is equal to a minus h. In case the h value is negative, here negative into negative, that is a positive, a minus is equal to a plus h. Now limit x tends to a minus f of x is equal to, that is limit h tends to 0 plus f of a minus h is equal to limit h tends to 0 minus f of a plus h. This is the left hand limit at x is equal to a. The same thing, the next one is right hand limit. The right hand limit at x is equal to a. The right hand limit at x is equal to a, that is equal to, it is limit x tends to a plus f of x is equal to. The same thing here, a plus x. A plus is nothing but a plus h. Yeah, this is the real line at x is equal to a. This is the right hand side. Now a plus is nothing but a plus h. A minus is nothing but a minus h. Okay. So now the same thing, then a plus is equal to a plus h. But here h tends to 0 plus, h tends to 0 plus, here a plus is equal to a plus h, but h tends to 0 plus, a plus is equal to a plus h. But h tends to 0 minus, a plus h is equal to a minus h. Okay. So now here a plus is equal to a plus h, a plus is equal to a minus h for different condition, h tends to 0 plus and h tends to 0 minus. Now same thing here, limit x tends to a plus f of x is equal to limit h tends to 0 plus f of a plus h is equal to limit h tends to 0 minus f of a minus h. This is the left hand limit at x is equal to a and right hand limit at x is equal to a. Now the limit existence. What is the limit existence? When the limit our existence, the limit existence is the left limit is equal to right hand limit, that is equal to L. L is nothing but it is a finite value. The left hand limit is equal to the left hand limit at x is equal to a. The left hand limit at x is equal to a. The right hand limit at x is equal to a is equal to the value, some finite value, then the limit is exist. Or the limit x tends to a, f of x is equal to L. The limit x tends to a, f of x is equal to L is nothing but f of x is approaching to L as x approaches to a. The f of x is approaches to L then x is approaches to a. This is the left hand limit and right hand limit and limit existency. Okay, the next one, then one discuss the basic problem. So what is the basic problem? For example, f of x is equal x square plus 2. Now f of x is equal to x square plus 2. Find right hand limit and left hand limit at x is equal to 2. Find right hand limit and left hand limit at x is equal to 2. Okay, now first of all, the solution, the left hand limit. So here I am taking again the real line. This is the real line at x is equal to 2. That is on right hand side. Then 2 plus is equal 2 plus h. Then left side, it is 2 minus is equal, it is on 2 minus h. This is the right limit, 2 plus, this is 2 minus is the left limit. I am taking the left hand limit at x is equal to 2. So left hand limit at x is equal to means it is on left side. Left side, it is nothing but the point is approaches to 2 but not equal to 2. I am taking for example x is equal to 1.9. X is approaching to 2, not x is equal to 2. So that's why I am taking x value, this is the x value 1.9. Okay, then x is equal to 1.9, then f of 1.9 is equal to 1.9 whole square plus 2. Then 1.9 whole square is equal to what? It is a 3.61 plus 2, that is equal to 5.61 at x is equal to 1.9. Then I am taking other x value, the x is equal to 1.99. That implies f of 1.99, that is equal to 1.99 whole square plus 2. So that is equal to 5.9601. Then similarly, at x is equal to 1.9999, then f of 1.9999 is equal to 1.999 whole square plus 2, that is equal to 5.96001. Then similarly x is equal to other value 1.999, f of 1.999 is equal to, that is equal to 5.960001. Now observe here, from left side, that is a left hand limit, the x value exactly not equal to 2. I am not taking exactly x not equal to 2. The x values are taking 1.9, 1.99, 1.999 something. Now observe here, the x value is approaches to 6. Observe here 5.9601, then 5.96001, then 5.96002. Then finally x tends to 2 minus, under the left hand limit, f of x is approaches to 6. Okay, then left hand limit at x is equal to 2 is equal to 6. Then similarly, right hand limit, the right hand limit at x is equal to 2. The right hand limit is nothing but that is on 2 plus. For example, after x2, here I am taking one value that is the x equal to 2.1. Then x is equal to 2.1, then f of 2.1 is equal to 2.1 whole square plus 2. So that is equal to 6.41. 6.41. Then x is equal to 2.11. Then f of 2.11 is equal to 2.11 whole square plus 2. That is equal to 6.041. Then x is equal to 2.111. Then f of 2.111 is equal to 2.111 whole square plus 2 is equal to 6.00401. This is the 401. Okay, then next x value we are taking 2.1111 something. The finally we are getting 6.000401. And finally the f of x it is reaches to 6. Then right hand limit at x is equal to 2 plus f of x is approaches to 6 and nearer to 6. That implies right hand limit at x is equal to 2, that is equal to 6. This method is not used, just for your understanding. This method is also known as value condition method. This method is known as value condition method. Okay, we are taking the real line. The real line at x is equal to 2. The point we are taking at x is equal to 2.1. Then after that x is equal to taking 2.11. Then x is equal to taking 2.111. So we get the finally the f of x is equal to some x square plus 2. That value is at x is equal to 6. The value is x is equal to 6. That is on left limit, either left limit or the right limit, the value is at x is equal to 6. Okay, so now going to the other method, the same problem will go to other method, that is on left hand limit at x is equal to 2. Left hand limit at x is equal to 2, that is limit h tends to 0 plus f of 2 minus h. Limit h tends to 0 plus f of 2 minus h. Now here f of x is equal to x square plus 2. Now here f of 2 minus h and is nothing but 2 minus h whole square plus 2. Okay, the before I explained a minus is equal to a minus h. A minus is equal to a minus h. Okay, then h tends to 0 plus a minus is also a minus h. So we are applying that formula here. The left hand limit at x is equal to 2, limit h tends to 0 plus f of 2 minus h. Because of here the limit exists at x is equal to 2. At x is equal to 2. So here a is nothing but 2. So that's why f of 2 minus h. Now here 2 minus h whole square that is equal to like a minus b whole square, a square plus 4 b square plus h square minus 2ab. So the minus 2ab is nothing but that is 4 h plus 2. So then that is equal to h square minus 4h plus 6. Now here h tends to 0. H tends to 0 means this value is going to 0. This value is also going to 0. Then finally the left hand limit at x is equal to 2 is 6. Then coming to similarly the right hand limit. The right hand limit at x is equal to 2. That is equal to limit h tends to 0 minus limit h tends to 0 minus f of limit h tends to 0 minus f of 2 plus h. That is equal to 2 plus h whole square plus 2. Then that is equal to 4 plus h square plus 4h plus 2. So that is equal to h square plus 4h plus 6. Then it is an h tends to 0 plus this value is going to 0. This value is also going to 0. Then substitute h is equal to 0 here. Finally we are getting 6. Then left hand limit at x is equal to 2. Left hand limit at x is equal to 2. That is equal to right hand limit at x is equal to 2 is equal to 6. Therefore, the limit is existing. The left hand limit and right hand limit is the same value. Therefore, the limit is exist. So, the directly means the limit x tends to 2 x square plus 2. Then substitute x is equal to 2, that is on 2 square plus 2, that is equal to 6. This method is called as a direct method. This method is called as a direct method. And x place lo, then substitute in the place of x in 2, then 2 square plus 2 is equal to 6. The limit value is 6. This method is called as a direct method. The before method, that h tends to 0 plus h tends to 0 minus, that method is useful for exclusively the problems mod x, greater integer of x, or mod x by mod x, and fractional of x, so on. So this type of problems we are using the h tends to 0, the left hand limit and right hand limit using h tends to 0 plus. Exclusively this type of problems. The other type of problems we are using direct method. Here I explained 3 types of methods. Here I explained 3 types of method to find a limit. The first method is that is only for your understanding. I explained that method. That method is called as a value condition method. Then we are taking some x is equal to 2.1, x is equal to 2.11, x is equal to 2.111. That is, so that method is called as a value condition method. That is for only for your understanding. The second method is a h method. Then h tends to 0 plus f of a plus h tends to 0 plus f of a minus h. This method exclusively for to solve mod x, greater integer x, and x by mod x, and fractional of x. To find a limit of exclusively for this, we use that h method. Otherwise, we are using the direct method. This is called as the direct method to find the limit. This is the three types of method I explained. So I am taking the one example. The question: check whether the following functions have limits at the mentioned points. So what is the function f of x is equal to? The f of x is equal to x plus 1, the x is positive, x greater than or equal to 0. Then f of x is equal to 1 minus 2x, the x is less than 0. This is the function. The check limits at x is equal to 0, 1. This is the problem. Check whether the following function have limit points. The function is given f of x is equal to x plus 1, x is positive, f of x is equal to x plus 1. Then x is negative, f of x is equal to 1 minus 2x at x is equal to 0, 1. Now I am checking at x is equal to 0, 1. Then 1 by 1. Now first at x is equal to 0. Now at x is equal to 0. At x is equal to 0, we are finding left limit and right limit. The same thing at x is equal to 1, we are finding left limit and right limit. The both left limit is equal to right limit, then the limit is exist. Otherwise, the limit is not exist. Okay, the left limit or right limit, it is not defined, the limit is not exist. In case the left limit is not equal to right limit, also the limit is not exist. When the limit are exist, only the left hand limit is equal to right hand limit, then the limit is exist. Okay, is it clear? Now here I am writing again the real line at x is equal to 0. This is the exactly x is equal to 0. Then x positive means the x is greater than 0. This is the x is greater than 0. This is the x less than 0. Then x greater than 0, what is the f of x? The f of x is equal to x plus 1. Okay, f of x is equal to x plus 1. The x is positive, x is negative, sorry, f of x is equal to 1 minus 2x. Okay, is it clear? This is the exactly at x is equal to 0. Okay, now first of all, at x is equal to 0, the solution at x is equal to 0, the first one, left hand limit. Left hand limit at x is equal to 0. The left hand limit at x is equal to 0 is nothing but that is an limit x tends to 0 minus f of x is equal to limit x tends to 0. 0 minus is nothing but that is an x less than 0. For x less than 0, f of x is equal to 1 minus 2x. Then here 1 minus 2x. Then substituting x value is 0. Then it is an 1 minus 2 into 0. Then finally the left hand limit at x is equal to 0 is 1. Then similarly the right hand limit. The right hand limit at x is equal to 0. Then that is a right hand limit is nothing but limit x tends to 0 plus f of x is equal to, then limit x tends to 0. Limit x tends to 0 plus is nothing but that is an x greater than 0. For x greater than 0, f of x is equal to x plus 1. Here the x plus 1, that is equal to, it is a 0 plus 1, that is equal to 1. Now here the left hand limit is equal to the right hand limit, the both are equal to 1. Therefore, the limit is exist at x is equal to 1. The limit exists at x is equal to, at x is equal to 0. The limit is exist at x is equal to 0. Now when coming to other limit at x is equal to 1, then check left limit and right limit at x is equal to 1. Then at x is equal to 1 means it is on positive. Then this is the exactly value at x is equal to 0. At x is equal to 1 is nothing but here, here at x is equal to 1. For at x is equal to 1, again the left hand limit, here left hand limit at x is equal to 1, that is equal to limit x tends to 1 minus, limit x tends to 1 minus f of x. The limit x tends to 1 minus f of x. At x is equal to 1, the left side is called as a 1 minus. The right side of 1 is called as a 1 plus. That is an right limit. This is the left limit. For both left limit, for right limit, for f of x is equal to x plus 1. For both the cases, at left hand limit or right hand limit at x is equal to 1, the f of x is x plus 1. Now observe this figure. Okay. Now limit x tends to 1 minus f of x is equal to, that is an limit x tends to 1, it is an x plus 1. Then substitute at x is equal to 1, x value is 1, that is an 1 plus 1 is equal to 2. Now the second one is the right hand limit. The right hand limit at x is equal to 1 is equal to limit x tends to 1 plus f of x is equal to limit x tends to 1, x plus 1 is equal to 1 plus 1, that is equal to 2. Just now I explained in both the cases the f of x is equal to x plus 1. Because of this is a in real line, this is the x is equal to 1. The x is equal to 1, the left side is and right side, that is a 1 minus and 1 plus in left limit and right limit. In both the cases f of x is equal to x plus 1. Then apply the limit x tends to 1. In left hand limit and right hand limit is the same. The value is 2. Therefore, the limit exists at x is equal to 1. Then left limit is equal to right limit, that is equal to 2. Then limit exists at x is equal to 2. This is the one example problem for limit. Yeah, we will discuss the another problem for limit. So the another problem is f of x is equal to, here I am taking f of x is equal to fractional of x. So find left limit and right limit. Find left hand limit and right hand limit at x is equal to 5. This is the problem. F of x is equal to fractional of x. Find left hand limit and right hand limit of at x is equal to 5. The fractional of x is nothing but x minus greater integer of x. Okay, here left hand limit at x is equal to 5. The left hand limit at x is equal to 5 is equal to limit h tends to 0 plus f of 5 minus h is equal to h tends to 0 f of 5 minus h is equal to, that is on limit h tends to 0 5 minus h, the fractional part of 5 minus h. Okay, so here let something h is equal to some 0.000001. Let h is equal to 0.001, very small value I am taking. Then 5 minus h is equal to what the 5 minus 0.000001, and is nothing but that is an 4.999999. Okay, the fractional of 5 minus h is equal to the fractional of 4.999999. Okay, that is called as the fractional of, means this is the value is 0.999999. The 0.999 is nothing but it is approaches to 1. So this is the left limit at x is equal to 5, value is 1. Then coming to right hand limit at x is equal to 5 is equal to limit h tends to 0 plus f of 5 plus h, f of 5 plus h, that is equal to limit h tends to 0 the fractional of 5 plus h. The fractional of 5 plus h is equal to, here already it is, let h is equal to that value, then 5 plus h is equal to, it is at 5.000001. Then fractional of 5 plus h is equal to fractional of 5.000001. Then the value is, it is a 0.000001. 0.00001 is nothing but it is nearer to 0. The right hand limit value is 0. Now observe here the left hand limit value is 1, the right hand limit the value is 0. Therefore, the left hand limit is not equal to the right hand limit. Therefore, the limit is not exist exclusively at the point at x is equal to 5. So this is f of x is equal to fractional of x is fractional of x. The limit is not exist exclusively at x is equal to 5. Okay, you observe to find the limits here, that is a 3 times already I told. The first one is the value condition method. The value condition method is the only for understanding purpose. That is a value condition method, means the x is equal to taking 0.2, 0.1, 2.11, 2.111 something. Okay, then other method is this h method, limit h tends to 0 plus f of a minus h, limit h tends to 0 plus f of a plus h. This method exclusively for some mod x, exclusively for some problems mod x or x by mod x, then fractional of x or greater integer of x, these type of problems using this method only. So that's why here the function is f of x is equal to fractional of x. So that's why I am using this method. So therefore the finally left hand limit is not equal to right hand limit. The limit does not exist at x is equal to 5. Okay, then we are going to explain the other example also. What is the other example? the greater integer x. What is the question? Then find the limit of x tends to 5 by 2. Find the limit x tends to 5 by 2 greater integer of x. Okay, so this type of problems we are using H method. The first left hand limit at x is equal to 5 by 2. Then left hand limit at x is equal to 5 by 2 is nothing but the limit s tends to 0 plus f of a minus h. Here a is nothing but 5 by 2. Then f of 5 by 2 minus h. F of 5 by 2 minus h. F of 5 by 2 minus h is nothing but limit s tends to 0. F of 5 by 2 is nothing but 2.5 minus h. Again we are taking let the h is equal to 0.0000001. H is equal to 0.0001. Then 2.5 minus h is equal to what? 2.5 minus h is nothing but the value is 2.49999. 2.4999 is nothing but that is equal to 2 because of this is the greater integer function. The greater integer 2.499 is nothing but the value is 2. Then here the left hand limit at x is equal to 5 by 2, the value is 2. Okay, and here we substitute what is that? The limit h tends to 0, the greater integer of 2.5 minus h is equal to 2. Then similarly, right hand limit at x is equal to 5 by 2. 5 by 2 is nothing but 2.5. Then limit h tends to 0 plus f of a plus h. A is nothing but here 5 by 2 plus h. That is equal to limit h tends to 0, 2.5 plus h. That is 2.5 plus h. Again 2.5 plus h is nothing but here 2.5 plus h. Then 2.5 plus h is nothing but that is equal to 2.50000001. Okay, that is equal to 2. That is a greater integer of x. So this value is also 2. Therefore here left hand limit is equal to right hand limit, that is 2. Therefore the limit exists at x is equal to 5 by 2. This is the problem. So now we discussed today we discussed neighborhood of a point, left neighborhood and right neighborhood. Then after that left hand limit and right hand limit. Then after we are taking one example, f of x is equal to x square plus 2. Using that example, I explained 3 types of methods. The one is the value condition method, the second one is the h method, the third one is the direct method. The h method is exclusively for to find a limit of some exclusively functions. What is the functions are called mod x, x by mod x, fractional of x, greater integer of x. This type of problems we are using the h method. The last method is the direct method. Then after that I explained 3 examples. Okay, thank you friends.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.